In this question, we're being asked to write a program to output the word hooray. So let's start by designing our algorithm. I'm going to use the double slash to indicate a comment. This is not quite correct in this language, but you're used to this in Java. So we'll go ahead with saying this is a comment. And the first thing we need to do is character output, uppercase H. And then I'll abbreviate a little bit. We want the O, another O, R, A, Y, and an exclamation point. So that's the end of our algorithm. Those would be the end of our instructions. And at the end of our instructions, we know that we have to put a double zero to indicate that that's the end. And now we're going to start an area where we will put our storage, for our storage. So let's think what we want to store. Over here we said H. So we need to store uppercase H. And if we look in our ASCII table, we will see that uppercase H is 48 hex. So here is our H. O is 6F, lowercase o. Now Hooray has two lowercase o's, but I don't have to store it twice. I just store it once and use it twice. So the next thing I need is an R. R is 7-2. A is 6-1. And Y is 7-9. Followed by exclamation point, which is 2-1. So I've kind of got my algorithm going along here. I've got to figure out now how I'm going to output the H. If I look in my instruction codes, I see that character output, I'll just type it here at the bottom, get rid of it in a minute, but character output is 0, 1, 0, 1, 0, AAA. Now the AAA stands for the mode, and we know that the mode is direct because we're going to say exactly what is the address of the thing we're trying to output. So instead of AAA, it's going to be direct, which is 001. And if I look at this in hex, this is 5-1. So for character output, it's going to be 5-1 followed by the address. I don't know what the address is right now, so I'll calculate them in a minute, but these are all going to be 5 1s because they're all character output. Okay. 5-1 followed by an address. So I have to figure out addresses next. So we always start with 0 as being the address of the first byte. And this instruction takes 3 bytes because the first byte is the 5-1 and the next 2 bytes are the address, which means that the next instruction is going to start at 0003. And this one will start at 0006, 0009. Again, that's the start of this instruction. So this instruction is going to take 9, A, and B, and this buddy here is going to start at C. This is going to take C, D, and E, which means that this guy starts at F. And this is the hard one. This is going to be F, 1, 0, 1, 1, which means that this buddy here starts at 1, 2. 1, 2, 1, 3, 1, 4. So this guy starts at 1, 5. And this is where lots of people make mistakes, so this is where you have to be careful. 1, 5 is the start of this byte. But there's only one byte. These were all 3s, but this is only one. This starts at 1, 5. Therefore, this guy is 1, 6. This guy is 1, 7. 1, 8. 1, 9. It's very tempting here to say 20, but it's not. It's 1A and 1B. Okay, let's get rid of that. It was just something I put there for you. So now I can go to these addresses and complete these instructions. I'm outputting the H. Where is the H? H is at 0016. So this becomes 0016. I'm outputting the O, 0017, and a second O, and 0018, 0019. The Y is at 001A, 001B, and that's the end of my instructions. At this point, I'm going to get rid of my comments. Just so that you can see the instructions a bit better. Okay, so these are our instructions now. When asked to do this on a test, this is what we need to see on the test. This is not quite what you have to put into the PEP 8, but this is what we want to see on paper on the test. So hopefully this is Hooray, and in order to check that, we're going to put it into PEP 8. When we do that, remember, we don't put the addresses in, we only put the instructions in, followed by ZZ at the end.